Hey, this is Ken Rosever. We're working on chapter or test 3 review here. And test item number 2 has us working with complex numbers and negative radicals. Or negative radicands. So right here on 2a, we see we have the square root of negative 48. The operation, or the directions say perform algebraically by hand, showing all work the indicated operation, and leave each answer in simplest or standard form without a negative radicand. So we can't leave the negative in there. So first thing I'm going to do is I'm going to get that negative out. How do I do that? Well, I'm going to show more steps than I have to here to be explicit, but this is negative 1 times 48. We know the square root of negative 1 is called I. The square root of 48 we can rewrite as the square root of 16 times 3, which gives us the square root of 16 is 4, so 4I times the square root of 3. You don't want to write I4 square roots of 3 because traditionally we put the I with the other radical because I is really a radical. So we write it in that order. What if you didn't see 48 was 16 times 3? Well, you could have done it like this. You could have said the square root of negative 1 times the square root of, I don't know, maybe you said 4 times the square root of 12. And you said this is a I, this is a 2, this is, oh wait, I can go further, the square root of 4 times the square root of 3. So it's 2I times, what's the square root of 4? 2 square roots of 3, which is 4I square roots of 3. So any way you do it, you should get the same answer if you did it correctly. Alright, so that's A. B has us multiplying two radicals with negative radicands. We know that when we multiply two radicals, let's say this times this, normally we can just put them under one radical and do the products of the radicands, which is 36, which is 6, right? Square root of 4 is 2, square root of 9 is 3, and we see that this way works, right? I can multiply the radicands and I can square root that and I got the same answer as I would the other way. But when the radicand is negative, we have to be a little more careful. The first thing we have to do is we have to get the negative out. So on this, let me just demonstrate. You cannot go like this. Well, negative times a negative is a positive, so that's going to be positive 36. You can't do that. It's not quite that easy. It's pretty easy, but not quite that easy. First thing you do is you blind these guys. You poke their eyes out. I know that's a bad joke. It's very morbid. But there you go. I'm going to pull the negative 1 out of here and call it I, because what is square root of negative 4? It's the square root of negative 1 times the square root of 4. And so I'm going to pull I out there, and it's going to be I square roots of 4. And then what am I going to do here? I'm going to do, this is I square roots of 9. And either by multiplying these together and getting 36 or doing them each individually, you'll get 6. But what will you have? 6I squared, which is I squared is negative 1, so it's negative 6 is our answer. So it's not 6. Okay, you can't cancel the negatives. And that's the key here. You have to be careful in your treatment of negative radicands. So on this problem that was given on the test, I'm going to pull out a negative 1. So the square root of negative 1 is a I. So I have this, and then I have this. The two i's I'm going to put as I squared, and then the square root of 24. You can do that But I'm going to go 24 times 6, and I think, yes, that is 144. And then I know this is negative 1, this is 12, so my answer is negative 12. Alright, not so bad. Let's go down to the next one. Alright, this has I raised to a power. So let's look at the pattern that occurs when we raise I to powers. I is the square root of negative 1. So I squared would cancel out the square root and give us negative 1. I cubed would take the previous answer I squared and multiply it again by I. So it'd be negative 1 times I, which is negative I. So that's I cubed. And then I to the fourth, you could say it's the previous answer times another I. And then you'd have negative I times I, which is negative I squared, but I squared is negative 1, so it'd be negative negative 1, which is 1. Or you could say that I to the fourth is I squared squared, which is negative 1 squared, which is 1. So I to the fourth is 1, either way you look at it. Well, what's I to the fifth? I to the fifth, where's my pen? There's my pen. I to the fifth is I to the fourth times 1, right? Or no, times I again. So it's 1 times I, which is I. Any fourth power of I to the fourth is 1. Let me explain this. All right. I to the fourth, I to the eighth, I to the 16th, I to the whatever, I to the negative 4, I to the 0 are all 1. How do I figure? Well, what's 1 to any power? 1 to any power, 1 to the n, right? 1 to the n is 1. Well, let's do a little substitution here. What is 1? 1 is I to the fourth. So I to the fourth to the n is 1. So I to the 4n, right? When we have a power to a power, we can multiply the power. So I to the 4n is 1. What's the 4n? 4n is any multiple of 4. Okay? Any multiple of 4. Any integer multiple of 4. If you take I to any integer multiple of 4, you get 1. Okay. So what's I to the 8th? What's I to the 12th? What's I to the negative 4? What's I to the negative 100? That's 1. Any integer multiple of 4, I raised to that power is 1. So how does that help us? Well, something we do with fractions, so that we can add fractions with different denominators, is we multiply by 1, don't we? And when we multiply by 1, we don't change the final value, we just make it easier to calculate. Right? Multiplying by 1 doesn't change the value of what precedes it. It just makes it easier for us to calculate that this is 9 plus 20 over 15, which is 29 over 15. So what did I do? I multiplied by 1 so that I could do the math. Up here, I'm going to multiply or divide by 1. What do I mean by that? I'm going to multiply or divide by I to a multiple of 4. So, or you could think of it like this. We'll do it a couple ways. So I to the 50th is I to the 48 times I squared, right? Because if you add the powers, if the bases are the same, you can add the powers. So you can think of I to the 50th as being 48 i's in a row and then 2 more after that. Well, I to the 48th is a multiple of 4 power. That's hard to say. I to the 48th is 1. And what's 1 times anything? Itself. So this is really I squared. And what's I squared? It's negative 1. Okay. Another approach you could take on this same problem is instead of splitting the 50 into a multiple of 4 and something that is not a multiple of 4, you could say divide the whole thing by 48. I to the 48. What's I to the 48? It's 1. So am I changing the value when I divide by 1? No, I'm not. Let me make this a little bigger so it's easier to write. Okay. So I could just divide this whole thing by I to the 48th, which I know is 1, so I'm not changing the value, but what is a division thing? The division rules say for exponents, if the bases match and we're dividing, we can subtract the exponents. So I'd be left with I to the 50 minus 48, which is 2, which is negative 1. Okay? And what am I doing there? I'm dividing by 1 to simplify. If I were a negative power, maybe I'd want to multiply. For example, if I had I to the negative 30, let's say. Well, if I go, let's see, what's a number I can multiply by? How about I to the 32? What's I to the 32? 32 is a multiple of 4, so I to the 32 is 1. That's cool. Can I multiply by 1? Yes, I can. Will it change the value? No. I'll get the same value as I started with, but in a form that is more digestible, something I can understand. And this also, let's see, when the bases are the same, we can add the powers. So this is I squared, which is negative 1. If I had I to the negative 17, I could add 20 to it, which is what? I to the 3. Why can I add 20? Because if I'm adding, I'm really multiplying, right? I'm just skipping a step. I to the 20 is 1. And what happens when the bases are the same? We add the exponents. So when I go negative 17 plus 20, I get I to the 3. I to the 3 is negative I. And there you go. So that's how you approach those problems. You need to know the pattern, and you need to know that you can, in the exponent, you can add or subtract multiples of 4 to reduce it down to something that's between 0 and 3 so that you can get your answer. Of course, if I gave you a multiple of 4, whether it be negative or positive, you already know the answer. The answer is 1. I to any multiple of 4 is 1. Alright, let me go over here now and do these last two problems.